So in part B of question 3, we're given that after a short time after the truck passing point B, truck R moves in a straight line on horizontal ground. We're applying the brakes, and we're given the rate of change of momentum. Now we need to define force. So force is just defined as the net force is just the rate of change of momentum. Like this. And we can show that the average resultant force F acting on a truck between 0 and 15 seconds is minus 1.2 times 10 to the 4. So, as we have just said, force is the rate of change of momentum. So we can take the final momentum, subtract the initial momentum, divided by the time. So our final momentum at t is equal to 15 was 2.5 approximately. And if we look at the initial momentum, that was 21. 21 times 10 to the 4, and then we divide this by 15 seconds. If we do this, we get minus 1.23 times 10 to the 4 newtons, which is indeed approximately minus 1.2 times 10 to the 4 newtons. Okay, then part 3, we have an identical truck S that has the same initial momentum, so 21 times 10 to the 4 as over here, kilogram meters per second. Truck S experiences a constant force equal to force F in B2. Stated explain whether truck S will take more or less time to come to rest as truck R. So here we have a constant force, so we can just use the F is equal to delta P over delta T formula, and then we just have minus 1.24 times 10 to the 4, and then the change in momentum will just be minus 21 times 10 to the 4, as the final momentum will be 0, and then we divide it by time. So if we do that, we get 17.5 seconds approximately, and then we can compare this with the other truck based on the graph. So if we come up here, we see that it's somewhere over here. We could say like 20, maybe like 22, 23 seconds to stop, maybe 22 and a half. So as we can see, for truck S is going to take less time. Truck S will take less time to stop. So that's that. We can say that TS is equal to 17.5 seconds, and this is smaller than TR, which was around 22 seconds.